Okay, we're now doing 1B. Notice that this has a even degree. So I'll just highlight here. This is an even degree, power of 4. So I've got that little chart that we talked about in previous pages in front of me, and also the behavior of the graph. So I'm going to focus on this part of the chart that I'm highlighting. It's negative in its lead coefficient. It's a -1 right here in front of x to the power of 4, and it's an even degree polynomial. Because it's a power of 4, it has 3 critical points, 1 hill and 2 valleys, or 1 valley and 2 hills. Okay, so it has 3 critical points. I'm just going to make note of that here, 3 CPs. Knowing those points would definitely help me graph this function. So I can already make a little assumption as to what this is going to look like. It's going to look like that tooth function, and since the leading coefficient's negative, it falls left, so it's going to go down over here. Notice I'm making a sketch of this. And it also, as x gets big, it falls to the right. So it's going to look something like this. Okay? It'll have 3 critical points, and from the chart, as x gets smaller, it falls left, and as x gets bigger, it falls right. So that will help me graph it. Now I'll set out to use my table of values to get a little bit more specific. Okay, table of values. When x is 0, it's easy to see through substitution that y will be 3. So that is my y-axis intercept. I'm going to label that right now, right here. Remember, we're doing these graphs with the assumption that we don't have our graphing calculator to graph, okay? But I'm going to use my graphing calculator kind of backwards to just get the points on the table, and then I'll graph before I look at the actual graph on my calculator. Now I'm going to start with 1. So I'm going to get ready here. Don't have that function typed in. I will pretend as if I do, though. I want to calculate these values. I want to save some time. So I'm just going to type that function in, negative x to the power of 4 minus 6x cubed minus 9x squared, and then plus 3. Okay, now I'm going to go to my home screen. I'm not even going to look at the graph. And I'm just going to go second function, calculate a value. I want the value when x was 2. Oh, it's going to graph it for me. Okay, pretend like you don't see that. I want the value of 2, enter, and it's negative 97. Okay, so back to my table. That's negative 97. It definitely falls left. Now to the 1. Second function, calculate a value of 1. That's negative 13. Negative 13. Negative 1. Second function, calculate a value of negative 1. That is negative 1. And then negative 2. Second function, calculate a value of negative 2. And we get negative 1 again. Negative 1. So let's just see what we got here. Let's label those points. 2 negative 97 is off the charts at negative 2, so let's put it way down here. 1 at negative 13 is a bit off the charts too. 1 negative 13, put it down here somewhere. Okay, 0, 3 we've got already. Negative 1. Negative 1 is right here. Negative 2, negative 1 is right here. Okay, I definitely need some more points. Okay, I know what's going on the right side for sure. I could actually just draw that right side in right now. Okay, it falls to the right, and it's falling from here infinitely down. Okay, it shouldn't be bending like that, but I'm drawing this with my mouse, so it's not too easy. Okay, so we need some more points. I need to get some smaller x values like -1, 2, 3, 4. Let's try -4. Okay, so let's continue this table over here. X and Y. I'm going to move this curve out of the way here. Get out of here. Okay, that's my guess graph. So -4. -4 input. -4. So -4. Second function, calculate -4. -13. Okay, that seems to be similar to something I've done before. -13. So we have a point now at -1, 2, 3, 4, -13. Okay. It would definitely be helpful if I could get another point around -4, like -3, because I'm not sure how this is going to bounce up. So let's do one more value at -3. At -3, second calculate -3, and we get 3. Okay, now I think we're in business. 3. So it's -1, 2, 3, 3. Now I've got something that resembles my original assumption quite closely over here. So I will give it my best shot to graph now. So it carries infinitely down to the left. It goes up to that point, -3, 3, and then it bounces down. It travels through to this point, and it's going to go below that point, and then it's going to bounce back up through that point and back to there. Make sure you have arrows on your graph for that nice tooth function. And hopefully yours looks better than mine. It should look like this. Okay, and if you want to double check your values, obviously you know how to use the table second graph to get the table. Okay, you can press stop for that example.